I hope you all are there. So, our today's lecture is going to be very interesting because it is related to electrolytic cells and electrolysis. And at the same time, we will discuss Faraday's laws of electrolysis. So, join fast. Yes, good morning all. So let us start today's session. It is electrolytic cells and electrolysis and Faraday's laws of electrolysis we will discuss, and after that we will cover NCERT and text questions, examples and NCERT exercise questions which are related to Faraday's laws. If you have any doubt, you can ask in between. So let us start the session. So first, what is electrolytic cells? So electrolytic cell, in its own word, electrolytic cell and galvanic cell, these are the two cells. In electrochemical cell, there are two types of cells, right? Electrolytic and galvanic or voltaic. So galvanic cell is the one in which chemical reaction takes place by its own and it will produce electric energy. But in electrolytic cell, we will use the external source of voltage to bring about a chemical reaction, because in electrolytic cell, the reaction which is going to take place is non-spontaneous. Keep in mind, non-spontaneous reaction takes place in this type of reactions. Got it? So wait for a second. One second. The glitch. Just hold for a second. Yes, I hope now you can see a cell which uses external source of voltage to bring about a chemical reaction, that is called electrolytic cell. right? So now it is an electrochemical process, but in this case, जैसे मैंने आपको बताया कि it is using external source of voltage to bring about a chemical reaction, because the chemical reaction taking place is non-spontaneous. That's why we use voltage, external source of voltage, or we can use battery to bring about a chemical reaction. So that is called an electrolytic cell. Now, what are the uses of electrolytic cell? So, electrochemical cell, it is very, very important aspect in the laboratory as well as chemical industry. It is one of the greatest important aspects in the lab as well as chemical industry. It is used in the extraction of metals, in the purification of metals, in the preparation of sodium hydroxide, preparation of production of hydrogen and oxygen from the electrolysis of water. There are so many processes. One of the example is extraction of metals from ore. That is one that uses electrolytic cell. Now, what is electrolysis? So, electrolysis, it is the process by which electric current is passed through a substance to effect a chemical change. And the chemical change, what is that chemical change? That involves a redox reaction, means in which substance either loses electron or gain electron, means oxidation or reduction takes place. And this process of electrolysis, it is carried out in an electrolytic cell. And just now we have discussed that electrolysis is used in many processes like extraction of ore, extraction of metal from ores, that is called metallurgy. So electrolysis is used extensively in metallurgical processes, right? Even purification of metals from the ores or compounds, or in the deposition of metals from the solution. Now, this metallic sodium and chlorine gas, they are produced by the electrolysis of molten sodium chloride. And electrolysis, if we do the electrolysis of aqueous solution of sodium chloride, that is sodium hydroxide and chlorine gas. Even just now I told you that hydrogen and oxygen are produced by the electrolysis of water. So these are all phenomena of electrolysis, and these are the applications of electrolysis. So one of the main teaser is here that 1 mole of positive charge is required to neutralize 1 mole of electrons. That means, what is charge on 1 mole of electrons? What is charge on 1 mole of electrons? The charge on 1 mole of electron is charge on 1 mole of electrons. Yes, tell me, what is the charge on 1 mole of electrons? Charge, charge on 1 electron is 1.602 into 10 raised per minus 19 coulomb. Now 1 mole, so it is 6.022 into 10 raised to power 23 per mole, right? So in this way it comes out to be 96,487 coulomb per mole. That is called 1 Faraday. means charge on 1 mole of electrons, that is equal to 1 Faraday, and approximately it is taken as, to simplify the mathematical calculations, we just use 96500 coulomb per mole. That is the charge on 1 mole of electron. Just note down it. It is very, very important. Charge on 1 mole of electron, that is 1 Faraday. 1.602 into 10 raised to minus 19 coulomb, that is the charge on 1 electron. And in 1 mole, there are 6.022 into 10 to 23 moles. So it is 96487 coulomb per mole. Okay. Good morning, Agam Bansal. So this is the charge on 1 mole of electron, and that is called 1 Faraday. Now, next is, if you have Na plus, then 1 electron is required to make sodium, or we can say to get 1 mole of sodium, 1 mole of electron is required, or we can say 1 Faraday electricity is required. In case of Mg2 plus, we need 2 electrons to get metal. In case of copper 2 plus, again we need 2 electrons. In case of aluminium 3 plus, we need 3 electrons. And to get chlorine from chloride ion, we will use 2 electrons. Means to get 1 mole of each or one of them, 1 Faraday of electricity is required for sodium, 2 Faraday for magnesium, again 2 Faraday for copper, 3 Faraday for aluminium, to get 1 mole of each. And to get 1 mole of chlorine gas, 2 Faraday of electricity is used. Now, quantitative aspects of electrolysis. Actually, to get this quantitative aspects of electrolysis, Faraday used his laws. Michael Faraday was the first scientist who described the quantitative aspect of electrolysis in 1833-34. And these are 2 laws. First law of Faraday's electrolysis and second law of Faraday's electrolysis. Now, let us discuss first law of Faraday's electrolysis. So, according to Faraday's first law of electrolysis, if you have sodium, let us say we have sodium positive. Now, sodium positive gain 1 electron to get sodium, right? That means if we pass 1 Faraday of electricity, that is 1 mole of electron is passed, then 1 mole of sodium is deposited. That means 1 Faraday of electricity will deposit 23 gram of sodium. Why is it so? Because atomic weight of sodium is 23. So mass of 1 mole of sodium is 23 gram. So if we pass 2 Faraday of electricity, we get 46 gram. If we pass 3 Faraday of electricity, we get 69 gram. That means as the quantity of electricity passing through the electrolytic solution increases, the amount of substance that deposited or liberated at any electrode during electrolysis increases. That means they are directly proportional. That means mass of the substance deposited is proportional to the quantity of the electricity passed to the electrolytic solution. Let us say Q is the quantity of electricity in coulombs and M is the mass of the substance. Then mass of the substance is proportional to the quantity of the electricity in coulombs. Now, you know, there is a proportionality sign. So to remove this proportionality sign, we use constant of proportionality, and this M becomes equal to Z into Q, and Z is called electrochemical equivalent. Now you know this Q, that the charge or quantity of electricity in coulombs, that is equal to I into T, because coulombs is equal to current in ampere and time in second. So if Q is in coulombs, then ampere into time in second is coulombs. So Q becomes equal to I into T. That means M becomes equal to, yes, M becomes equal to Z into Q, and M is equal to Z into I into T. Now this Z, what is this Z? That is electrochemical equivalent, that is equal to E upon 96,500, and where E is the equivalent weight. Z, you know, that is electrochemical equivalent, and this equation is called first law of Faraday's electrolysis. Now this equivalent weight, how do we calculate equivalent weight? For example, if we have Mg2 plus, it will gain 2 electrons to get Mg solid. So equivalent weight is equal to molecular weight or molar mass, we can say, molar mass upon number of electrons gained or lost. So in this case, equivalent weight of magnesium is molar mass of magnesium, that is 24, divided by electrons gained or lost. So it comes out with 12. So equivalent weight of magnesium is 12 gram per equivalent. 12 gram per equivalent. Same if we have aluminium. So in case of aluminium, it gains 3 electrons. So equivalent weight of aluminium is molar mass of aluminium, that is 27, divided by 3. So that is 9 gram per equivalent. You know, molar mass, it is gram per mole, and equivalent weight is gram per equivalent. Means to calculate equivalent weight, you need to know molar mass only and how many electrons gain or lose. So thus just equivalent weight is molar mass divided by number of electrons gained or lost. So this is Faraday's first law of electrolysis. That amount of the substance deposited or liberated at any electrode is equal to equivalent weight into current in ampere, time in seconds, divided by 96500. So this is mathematical formula of first law of thermodynamics. Sorry, first law of electrolysis, Faraday's electrolysis. Now second law of Faraday's electrolysis. So in second law of Faraday's electrolysis, You know, in Faraday's second law of electrolysis, if same quantity of electricity is passing through the different electrolytic solutions, then amount of the substance deposited or liberated at electrodes during electrolysis, that is proportional to their electrochemical equivalent weights. Let us say we have three cells connected in series. First contain H2SO4, dilute H2SO4. Second cell contains copper sulfate, and third cell contains silver nitrate. So, amount of hydrogen deposited at first electrode, amount of copper deposited at second electrode, amount of silver deposited at third electrode. How do we calculate? Let us say M1 and M2 that is the mass of substances. E1 and E2 their equivalent weights. Then ratio of the mass deposited is equal to ratio of their equivalent weights, or we can say M1 upon E1 is equal to M2 upon E2. So M1 upon E1 is equivalent number of equivalents of substance 1, that is equal to number of equivalents of substance 2. If same quantity of electricity is passed through each electrode or electrolytic cell. So this is a simple funda. M1 by M2 equal to E1 by E2. That is second law of electrolysis. See, if same quantity of electricity is passing through the different electrolytic solutions, then amount of the substance deposited or liberated at electrodes during electrolysis is proportional to their equivalent weights. That's it. So let us solve this question. That is, a solution of copper sulfate is electrolyzed for 10 minutes with a current of 1.5 ampere. So what is the mass of copper deposited at the electrodes? Copper. In copper sulfate, you have copper 2 plus and SO4 2 negative. So in copper 2 plus, how many electrons it will gain? So obviously to get copper, it gain 2 electrons. So number of electrons gained, or we can say valency of copper, is 2. So what is equivalent weight of copper? Equivalent weight of copper is its atomic weight, that is 63.5. Generally it is given to you. Atomic weight of copper should be given to you. So divided by 2. 63.5 divided by 2, that is the equivalent weight of copper. Now, according to Faraday's first law, of electrolysis, mass deposited is A into I into T upon 96500. E, it is 63.5 upon 2. And what is I? That is 1.5 ampere. And time is in minutes. So 10 into 60 seconds. Sorry. So it is 10 into 60. So this much amount of copper is deposited. Simple funda hai. Okay. So So equivalent weight of copper is 63.5 upon 2. Time in second, that is 10 into 60, 600 seconds. Current in ampere, 1.5. So quantity of electricity is 1.5 into 600, 900 coulombs. So mass is equal to E into Q upon 96500. In this way you can do. It is up to you. So value comes out to be 0.29 gram. Okay. Now next is in text question 10. This was the example 10. So in text question, if a current of 0.5 ampere flows through a metallic wire for 2 hours, then how many electrons would flow through the wire? So you know, current is 0.5 ampere and time is, you should need time in hours, sorry, in seconds. So time is given in hours. So 2 into 60 into 60, that become seconds. So 0.5 into 2 into 60 into 60. So that is 3600 coulombs. That is the quantity of the charge. And what is the charge on 1 mole of electrons? That is 96,500 coulomb. That is 1 mole of electron charge. And 6.02 into 10 raised by 23 electrons, they are in 1 mole. So 6.02 into 10 raised by 23 electrons, that is 96,500 coulomb. So 3600 coulomb is equivalent to, 6.02 into 10 by 23 divided by 96,500 into 3600. So 2.246 into 10 raised by 22 electrons. Got it? You can do it like this. This also, quantity of electricity is 3600 coulombs. And if we see the charge on 1 electron, that is 1.602 into 10 raised by 23, sorry, 6.022 into 10 per minus 19 coulomb. That is charge on 1 electron. So number of electrons into 1.602 into 10 raised by minus 19, that is equal to 3600 coulombs. So number of electrons is equal to 3600 divided by 1.602 into 10 raised per minus 19. So in this way, it is 3.6 upon 1.602 into 10 raised per, see, 3.6 means 10 power 3 plus 19. So it is 10 power 22. So in this way it comes out to be, so this is the second way to solve this question. That quantity of charge we have, that is 3600 coulombs by using this formula, and then we will go like this, that charge on 1 electron is this. So charge on 1 electron multiplied by number of electrons is equal to 3600 coulombs total charge. So number of electrons comes out to be in this way. Next question, in text question 12. Consider the reaction Cr2O7 2 negative plus 14H plus 6 electron to give 2 Cr 3 plus 7H2O. What is the quantity of electricity in coulombs needed to reduce 1 mole of dichromate? So to reduce 1 mole of dichromate, 6 mole of electrons are required, and charge on 1 mole of electron is 96500 coulomb. So for 6 mole, it is multiplied by 6, so it is 579000 coulombs. So this much of electricity are required for reduction of 1 mole of dichromate to Cr3 plus. This is very simple. Charge on 1 electron, charge on 1 mole of electrons. That is equal to 1 Faraday, and 1 Faraday is 96500 coulomb. So charge on 1 mole of electron is this. So charge on 6 mole of electrons, that is simple, 6 into 96500. That's it, because 1 mole of dichromate requires 6 mole of electrons to reduce into Cr3 plus. Okay, next. This is the question from exercise. It is 2.10 nowadays because syllabus has been changed. And next, it is 2.12 intext question. Now it is from NCERT exercise. Twelfth question. How much charge is required for 1 mole of aluminium 3 plus? So aluminium 3 plus, 3 electrons to aluminium. That means to get 1 mole of aluminium, 3 mole of electrons should be passed through it. That means 3 Faraday of electricity is required. For copper 2 plus to copper, one mole, we need 2 mole of electrons, means 2 Faraday of electricity is passed. You can see 3 Faraday, 2 Faraday. Last one, keep in mind, it is MnO4 1 negative. It is MnO4 1 negative. So we need to calculate oxidation number of manganese first. So in MnO4 1 negative, take manganese as X, oxygen minus 2. So oxidation number is X minus 8 equal to minus 1. So X is minus 1 plus 8, means plus 7. So it converts from Mn plus 7 to Mn2 plus. So 7 plus to 2 plus. So 5 electrons are required. So 5 Faraday electricity is used, and then 5 into 96,500 coulombs. This is value in coulombs. Hey, it is written how much charge is required. So you can report the result in Faraday only. And if you want to go next step, means to get in coulombs, just multiply it by 96,500. Otherwise, there is no need to multiply, okay? Next, how much electricity in terms of Faraday is required to produce 20 gram of calcium from molten CaCl2? So, in molten CaCl2, CaCl2 will give Ca2 plus and 2Cl negative. So to get calcium from calcium 2 plus, 2 electrons are used. So 2 Faraday of electricity to get 40 gram of calcium. So to produce 40 gram of calcium, charge needed is 2 Faraday. It is calcium actually. And to produce 20 gram of calcium, charge needed is only 1 Faraday. Okay. Second, Al2O3 plus how many electrons? See, in Al2O3, again molten Al2O3. So in Al2O3, there are 2 aluminium 3 plus, 3 O2 negative. So aluminium 3 plus will gain 3 electrons to get aluminium. You can go like this as well as in this way. 3 Faraday of electricity deposits 27 gram. So to deposit 27 gram, we need 3 Faraday of electricity, or to deposit 54 gram, charge needed is 6 Faraday, and to deposit 40 gram of aluminium, charge needed is 40 divided by 54 into 6. So it is 4.44 Farad. So that is NCERT exercise question number 13. Now 14. How much electricity is required in coulomb for the oxidation of 1 mole of H2O to O2? This is again NCERT question. 14. 1 mole of H2O to O2. So you know H2O gives O2 like this because it is only 1 mole. So hydrogen 1 mole and oxygen we get half mole. So to get this half mole of O2, we need 2 electrons. O2 negative ion will give half O2 plus 2 electrons. So quantity of electricity required is 2 Faraday. That is 2 into 96,500 coulomb. That is 193,000 coulomb. Next is 1 mole of FeO to Fe2O3. So electrode reaction for 1 mole of FeO is like this, because in FeO iron is 2 plus and in Fe2O3 iron is 3 plus. Because in 1 mole of FeO there is only 1 Fe2 plus. So 1 Fe3 plus is formed plus 1 electron. So 1 Faraday of electricity is used to convert FeO to Fe2O3, and therefore quantity of electricity is 1 Faraday, that is 96,500 coulomb. Again keep in mind, what is 1 Faraday? 1 Faraday is charge on 1 mole of electrons. Always keep in mind this, that 1 Faraday is charge on 1 mole of electrons. Now second last question. A solution of nickel nitrate is electrolyzed between platinum electrodes using a current of 5 ampere for 20 minutes. So what mass of nickel is deposited at a cathode? Okay, so in this case, you know, current is 5 ampere, time is 20 minutes. So 5 ampere and 20 minutes. So convert this time in seconds. So it is 2 into 60. That means 5 ampere into 20 into 60 means total 6000 coulombs. So 6000 coulombs of electricity is passed through nickel nitrate solution. So we need to know what is the mass of nickel deposited. So in nickel nitrate, what is the charge of nickel? What is the oxidation state of nickel? 2 plus. So nickel 2 plus 2 electron to give nickel. That means 2 Faraday, or we can say 2 into 96,500 coulombs electricity is passed through nickel to deposit 1 mole. So 1 mole of nickel is 58.7 gram. So 6000 coulomb of charge will deposit in 58.7 divided by 2. Why 58.7 divided by 2? Because equivalent weight of nickel is 58.7 divided by 2. Okay. इस सेम क्वेश्चन हम कैसे कर सकते थे? जस्ट वी कैन अप्लाई Faraday's first law. Yes, you can write that according to Faraday's first law of electrolysis, mass deposited is equivalent weight into I into T upon 96,500. Now equivalent weight of nickel, तो यहां से आ जाएगा nickel 2 plus 2 electron to nickel. Equivalent weight of nickel is atomic weight of nickel divided by 2. That is 58.7 by 2, and current in ampere, so that is 5, and time is given in minutes. So we write 20 into 60 into 96500. Time is 20 minutes. So 20 into 60 seconds. Just write it like this and you get the answer. You can go like this. That equivalent weight is 58.7 upon 2, because in nickel nitrate, nickel is 2 plus, gain 2 electrons to get nickel. Okay, last question. That is 16, 2.16. 3 electrolytic cells A, B, C. First is containing solution of zinc sulfate, second containing silver nitrate, third containing copper sulfate, are connected in series. जैसे ही आपने पढ़ा it is connected in series, so आपको क्लियर हो गया कि we will apply Faraday's second law. So according to Faraday's second law, M1 by M2 is equal to E1 by E2. Right? Then a steady current of current is given 1.5 ampere, pass through them until 45 gram of silver deposited. Is weight of silver deposited is given at the cathode of cell B. So how long did the current flow? Means we have to calculate time. So according to Faraday's first law of electrolysis, मास डिपॉजिटेड, इसका मास दिया आपको सिल्वर का, दैट इज इक्विवेलेंट वेट ऑफ सिल्वर इंटू आई इंटू टी डिवाइड बाई 96,500। तो इनमें टाइम क्या जाएगा, मास ऑफ सिल्वर डिपॉजिटेड इंटू 96,500 डिवाइडेड बाई इक्विवेलेंट वेट ऑफ सिल्वर इंटू करंट, और वाइस वर्सा करंट इंटू इक्विवेलेंट वेट, ऐसे कर दो तो टाइम आ जाएगा, कितना आएगा सेकंड्स में। मास कितना है 1.45 ग्राम, 96,500 कूलम, करंट इज 1.5, इक्विवेलेंट वेट ऑफ सिल्वर। अब आपको बताया कि सिल्वर नाइट्रेट में सिल्वर इज 1+ and equivalent weight of silver is its atomic weight divided by 1, so 108. So in this way we put these values and we get 863.73 seconds. बस इतना सा करना था, जस्ट फॉर्मूला पुट करो, वैल्यू आ जाएगी। देन व्हाट मास ऑफ कॉपर एंड जिंक वर डिपॉजिटेड। अब आपको पता है कि फैराडे सेकंड लॉ लगेगा, W1/W2 और E1/E2 इक्वल टू W1/W2 इक्वल टू E1/E2 और M1/M2 इक्वल टू E1/E2। मास को आप वेट भी लिख सकते हो इन ग्राम्स। सो आपको एक का वेट तो दिया है सिल्वर का, इक्विवेलेंट वेट सबके निकाल लो आप। देखो फर्स्ट सेल में जिंक 2+ है, 2 इलेक्ट्रॉन गेन करेगा, बनाएगा जिंक। कॉपर 2+, कॉपर सल्फेट में कॉपर 2+, कॉपर 2 इलेक्ट्रॉन गेन करेगा। सिल्वर Ag1+ भी Ag। तो इक्विवेलेंट वेट ऑफ जिंक जो है दैट इज 65/2, इक्विवेलेंट वेट ऑफ कॉपर इज 63.5/2 और सिल्वर जो है दैट इज 108/1। तो पहले का वेट ऑफ जिंक निकालना है, तो वेट ऑफ जिंक डिवाइड बाय वेट ऑफ सिल्वर इज इक्वल टू इक्विवेलेंट वेट ऑफ जिंक डिवाइड बाय इक्विवेलेंट वेट ऑफ silver. That implies weight of zinc deposited equal to equivalent weight of zinc, equivalent weight of silver into weight of silver. तो equivalent weight of zinc कितना है 65/2, silver 108 और weight of silver deposited is 1.45। तो इस तरह से यहां से आपके पास आ जाएगा वेट ऑफ जिंक डिपॉजिटेड इन ग्राम, सेम वेट ऑफ कॉपर, वेट ऑफ सिल्वर, इक्विवेलेंट वेट ऑफ कॉपर, इक्विवेलेंट वेट ऑफ सिल्वर। दैट इंप्लाइज वेट ऑफ कॉपर डिपॉजिटेड इज equivalent weight of copper, equivalent weight of silver into weight of silver। अब क्या आ जाएगा 63.5 divided by 2 into 108 into 1.45। So in this way you will get the answer। देखो ऐसे है ना, कॉपर के लिए W1 1.45 ऑफ सिल्वर, E1 108, W2 निकालना है कॉपर का, E2 63.5 डिवाइड बाई 2। तो फैराडे सेकेंड लॉ लगा दो, 1.45 अपॉन W2 इक्वल टू 108 अपॉन 31.75, W2 आ जाएगा। वैसे ही जिंक के लिए भी W2 निकालना है। अब E2 चेंज हो जाएगा, क्योंकि 65/2 होगा, ठीक है। और इन दिस वे यू विल गेट द वैल्यू 0.438 gram of zinc. So that's all for the day. Thank you so much. If you have any doubt, you may ask. Reteach. Oh, sorry. Which one? I'm sorry, actually मैंने यहाँ देखा ही नहीं। कौन सा स्टेप बेटा? कौन से वाला स्टेप बेटा? मुझे सॉरी, जो भी हो आप। थैंक यू मैथ्यू। ये कौन से स्टेप की बात कर रहा था बच्चा? आई डोंट नो। ओके, गॉड ब्लेस यू ऑल, थैंक यू सो मच।